Hot Rods is the largest manufacturer of aftermarket connecting rods and crankshafts in the power sports industry, with applications from 50cc to 1300cc engines for motorcycles, ATVs, UTVs, snowmobiles, and personal watercraft. Originally produced in Taiwan, Hot Rods has transitioned its rod manufacturing to their headquarters in Urbandale, Iowa, bringing to market some of the highest quality connecting rods and crankshafts available. Before any manufacturing process begins, each dedicated forging is sent to the Quality Control Department for inspection. The Quality Control team inspects the forging using an engineering file to ensure that the forging number, the dimensional measurements, and the material properties are all correct. After the forgings have passed inspection, each batch is marked with a green sticker and prepared for copper plating. Any forgings that fail inspection are set aside and quarantined. The forgings are copper plated to protect the material from the carbon gases used during the heat treatment process. After the forgings have been copper plated, they are again inspected by Quality Control to ensure proper plating thickness and plating adherence quality. The thickness of the copper is critical to the hardness of the material and the overall dimension of the forging. The plating is inspected with a plating scanner to ensure a minimum thickness of 1/1000th of an inch. If the plating is too thin, the entire rod will become too hard and brittle and can lead to breakage. Adhesion quality of the plating is inspected using a file to ensure the plating won't flake off during the machining processes. Any rods failing inspection are sent back to have the plating stripped off and then replated. After inspection, the rods are sent to the machining department to begin the machining processes. The first step in the machining process is grinding the initial width or rough grinding of the rod to a specified dimension. This specialized grinder establishes a perfectly flat surface on each side of the forging. This is critical to ensure further accuracy in the following steps of the machining process, as this surface is used as reference point. It takes about 20 seconds for all 4 surfaces of the rod to be simultaneously ground on the CNC grinder. When each rod is removed from the grinder, they are inspected by the operator using a micrometer to inspect the overall width of the surfaces. The tolerance is held within 5 microns or 2/10,000th of an inch. This inspection of each rod ensures that any rod that may be out of tolerance is eliminated from going any further in the production process, thus saving time and money. After each rod is rough ground, they go into a vertical CNC mill for machining. The rods are then put in a CNC mill to machine all of the internal and external features of the rod. A special holding fixture is used so the mill can cut the internal dimensions and features of 3 rods and the external dimensions and features of 3 rods at the same time. The mill begins by cutting the internal features of each rod. This includes the bearing surface bores, chamfers on both sides of the rods, and any oiling grooves or holes. The mill then switches to the features on the outside surfaces of the rods. This includes the specially designed vent slots in the big end of the 2-stroke rods and the oiling holes in the small end of the rod. All of the final outside dimensions are then cut to their final specifications. Using calipers, the mill operator also inspects the rods for wall thickness and width on each end. He then deburrs each feature of the rod by hand. This must be done before heat treatment because afterwards the rods will be too hard to be deburred. While the mill operator inspects the rods by hand throughout his production run, at the beginning of each new production batch and the start of each new shift, 1 rod from each fixture station in the mill, 3 total, are sent back to the Quality Control Department for inspection on the coordinate measuring machine. The CMM operator inspects all of the critical dimensions of the rod. This includes the center-to-center of bearing holes, the overall length, the individual diameters of the rod bearing and wrist pin bores, the overall width of the rod at each end, and checks for parallelism and any twist of the rod. This thorough inspection ensures that each mill is set up and operating correctly. After the rods have been machined on the mill, they are then put into totes and sent out for heat treatment. Keeping the rods in these plastic totes is an efficient way for the production team to track the progress and location of each batch of rods, while also keeping them from contacting each other during transport to heat treatment. The bearing surfaces of the rods must be hardened so the rods are shipped out to be heat treated. The rods are first placed in a specially designed holding fixture to reduce any distortion caused by the heat treating process. After the rods are fixtured, each batch is placed into a furnace for 10 hours. After 10 hours inside the furnace, the rods are quenched in oil and come out to go through a hot water bath. After the oil is rinsed, the rods are then placed in a tempering oven and brought back up to 350 degrees. This specialized process is critical in ensuring the hardness of the bearing surfaces of each rod before they get finished, ground, and honed. After heat treatment, the rods are returned to be finished ground to their final specified width. Going through the CNC grinder a second time, this last grinding process is the most critical to ensure the rod surfaces are perfectly straight, because after heat treatment, the surfaces become distorted. The grinder makes each surface perfectly flat within 5 microns or 2/10,000th of an inch, and each part is hand inspected by the operator with a micrometer for overall dimensional consistency. If the surface of the rod is not perfectly straight, then it would be impossible to get the bearing holes exactly perpendicular to the sides of the rod during the honing process. After the rods have been finished ground, they are placed in a vibratory deburring machine with ceramic stones that remove any sharp edges created in the machining processes and to smooth the surfaces. After the rods have circulated through the ceramic stones, they transition into a mix of ground corn cobs to finely polish the surface. This process ensures that all the surfaces of the forgings are smooth and polished, providing a high-quality finish. The rods then move to their last machining station, which is to hone the bearing surfaces. Honing the bearing surfaces is the last but very critical machining process. The rods go through 2 honing stations. The first station is for the large bearing hole, and the second station is for the smaller bearing hole. These steps are critical in ensuring a perfectly round, smooth, and perpendicular hole at each end of the rod. The 2 hones smooth the bearing surfaces to within 18 micrometers. This is critical for high RPM use and bearing longevity. Initial production run pieces are inspected in the quality control room on the CMM machine for proper dimensions. Then the hone operator hand inspects every piece for perpendicularity, parallelism, and bore size throughout his production run. The rods are then dunked in an anti-rust bath to protect them from corrosion. Agitating the rods in an anti-rust bath protects the rod from oxidation and moisture until it is ready to use. After this process, to prevent any oxidation from the salts and oils in our skin, the rods are only handled by personnel wearing rubber or latex gloves. After all the machining is done and the rods have gone through the anti-rust bath, each part gets laser etched with the production batch number, part number, and most importantly, made in USA on the beam of the rod. The batch number can be used to identify every aspect of the rod's production cycle: what day it was made, who made it, and when it was finished. The part number is used to identify the rod, whether in the warehouse or after it has been installed in an engine. And again, after etching process, the rods visit the quality control department for visual inspection of the etching, then they are sent off to packaging. After the rods have gone through their last quality control inspection for laser etching, they are ready to be packaged. Rods that are shipped to Hot Rod's crankshaft factory for assembly onto crankshafts are first sealed in an anti-rust bag, then packaged onto plastic trays to be shipped. After the factory has assembled the rods onto crankshafts, the plastic trays are then returned to be reused. Connecting rods and components that are packaged for individual sale as Hot Rod's connecting rod kits are pulled from inventory using a specific bill of material. Those list the individual part numbers for the connecting rod, rod bearing, crank pin, thrust washers, wrist pin bearings, the decal, the box, and even the anti-rust bag. Then, just to ensure the packaging personnel have pulled the correct parts from the BOM, a quality control person visits the packaging area to double-check the correct parts go into each rod kit. After the rods have been sealed and packaged for individual sale, they are put on the shelf until they are pulled to fulfill orders for customers worldwide.